Alright, if you look at section 2.7, they give you a bunch of different formulas, like 7 of them actually. But there's only really 2 formulas that are here. The first one is the old formula, which is just a slope formula, but you're taking the limit of a slope formula. Okay, and they call that definition 1. Now they also mention it later on in the same form as equation 5 and equation 6, or definition 5 and definition 6. But the main one that you want to focus on the best is the one that works the best is number 4 here. Now they might call it equation 2 or definition 3 or definition 4, but they're all doing the same thing. They're taking the limit. It's just whether they call it m or velocity or first derivative. It all is the same thing. It's the same formula, and this is your difference quotient. It's just f of a plus h minus f of a over h. Now sometimes they keep a in a general form and they don't tell you what a is. And other times they tell you what a is very specifically, like a is 1 or a is 3. The questions vary. But in general, in this section, there's only 2 types of questions. There's questions where you're taking the limit of the slope formula, or there's questions where you're taking the limit of the difference quotient. Alright, so let's look at some of the questions here. The first one, they say, using definition 1, find the slope of the tangent line. So definition 1, if you look back here, definition 1 is your slope formula. So you can see you have slope formula because you don't have an h in the denominator. So f of x minus f of a over x minus a, and they nail down what a is and they tell you a is minus 1. That makes it a lot easier to do. When you multiply everything out and expand it, you should be able to factor the top. Typically, it will cancel with the bottom, and at that point you can do direct substitution and you get an answer. Now, if you do the same problem using equation 2 instead of definition 1, you're now doing the difference quotient. And here they can give you a general a, or they can nail down what a is. Here they're telling you what a is, makes it easier. So you just figure out what f of this is, f of that is, and multiply it out, expand it. And a bunch of stuff's going to cancel, and you should only have things left that have an h in them, which will each cancel with your h in the denominator. I actually should have plus 3h here, and your h will cancel with that, and you should have, well, no, that's not plus 3h. It's minus 2h plus 3h is plus h. No, that's fine. So you cancel an h and you get h plus 1. You do direct substitution, put 0 in for h, and you get 0 plus 1 is 1. So there's your slope is 1. No matter which way you do it, you get the same slope. Then they ask you to find the equation of a line given the 1 point in the slope. I now think we can do that. That's not a problem. This one says find the equation of the tangent line. So we have to find the slope, and we use equation 2, difference quotient, with a equaling 3 instead of a plus h and a, we're using 3 plus h and 3. Put everything inside the functions properly, expand everything out, cancel an h, plug in 0 for h here, and you get 7. And now that you know it's 7 and you got 3 over 4, or 3/4 is your other point, you can find your slope. This one goes back to using equation 1, and they tell you that a equals a very specific number of -1. So they're asking you to do f of x minus f of a over x minus a. So here's your f of x, here's your f of a. When you plug in minus 1 into the function, you get minus 2. And minus 1 in here for a, that's what a equals in this problem. You get it to this point, and you can't do direct substitution because you'd be dividing by 0. So you have to multiply by the conjugate top and bottom. When you do that, it simplifies down to here. If you factor out a minus 3 and x plus 1 will cancel, now you can do direct substitution and you're no longer dividing by 0 and you get an answer. This is dramatically harder than when you do the difference quotient. The difference quotient is a simpler way to do it. In this question they ask you to interpret what's happening in this graph. This is as time goes by, this is how many meters you are from a certain point. And so this is a person after 1 second has advanced 3 meters, and then 1 more second they've advanced 0 meters, and then 1 second later they've come back 2 meters. They've not moved at all in that second, and then for the next 2 seconds they advance 2 meters further away. And so if you were to graph the first derivative, it would just simply be those 5 different slopes. You got a slope here of 3, you got a slope here of 0, slope here of negative 2, another one at 0, and then another one at positive 1. 5 says use definition 1 to find the velocity or first derivative. Okay, and so you take s of t minus f of 1 over t minus 1. You plug that in for the function, and you plug 1 into the function, you get 25. You multiply everything out, expand everything out, factor, things will cancel. Now you can do direct substitution and you get an answer of 9. This one's using the difference quotient with a equaling 1. So you're plugging in 1 plus h instead of a plus h into the function. You expand it out. Okay, so this guy with 1 plus h gives you this whole thing here, which we already calculated earlier, minus the function when you plug in 1, you get this. And now when you drop your brackets and cancel terms, all you have are terms that have an h left in them, which will cancel. At this point, when you plug in 0, this guy goes away, and your answer is just 6.28. This one is asking you to do the same question, but they're not allowing you to let a equaling 1. They want to use a general case a. So it's a lot harder. When you multiply everything out, you get this big long mess, and you get this guy as well for the second guy. When you drop your brackets, a bunch of stuff cancels. What you got left here, and each one has an h in it, which will cancel. And then when you plug in 0 for h, this part goes away, and you just get the first 2 terms as your first derivative. Notice that if you let a equal 1 here, you get your answer for that one. So this is a specific case just for a equals 1. This is a general case for any a. This is a lot better answer if you're just talking about the slope of a function for any given number. And then they ask you, when does the rock hit the surface? You calculate when the function equals 0, and at either of those 2 points you plug that into the function and you find the velocity at that moment when it does hit the surface. This one, it gives you g of 5 equals negative 3, so that lets you know that 5, negative 3 is on your graph. G prime of 5 equals 4, that means your slope is 4 at x equals 5. So now that you got your slope is 4 and you got your point, you can find your equation of a line. And you can do the same thing here. And you, well, they actually give you 2 points, 0, 2, and 4, 3, and you have to use the slope formula to find the slope. And so that's how you find that what f prime of 4 is, by actually doing the slope formula there. 29, we're doing the difference quotient with a equaling 1. So you plug in 1 plus h into the function, expand it out, plug 1 into the function and multiply it out. Things cancel. You're left with only terms that have an h in them. They cancel in their own way. Now when you plug in 0 for h, you get 3. And since your slope is 3 and your point is 1, 2, you can now find the equation of a line. 23, we're using a difference quotient here, but we're using a non-specific a. We're not nailing down what a is to be a specific number. So we multiply everything out. It's a bit more complicated. A bunch of terms cancel. Typically the terms that do not have an h will cancel. And all the terms that do have an h will each be divided by h, and you'll get this. And when you plug in 0 for h, this term goes away and you just get 4a subtract 5 as your derivative. Same idea here for a general case. Alright, so you plug in a plus h for t here, and you get this guy minus this guy all over h. I multiply the top and the bottom by these common denominators, and when I do that, when you multiply both denominators times this fraction, this denominator cancels with that, and you're left with the other denominator times the numerator, just 1. And this one over this times this, these two cancel, and you're left with just this guy times 1 as your second term, set of terms. And then on the bottom you still have your h, and you still have your 2 different denominators there. Now you expand everything out, and a bunch of stuff cancels, and then you can factor out an h, and you can cancel with your denominator. Now when you plug in a h, 0 for h, you don't get division by 0 anymore, and you do get a very specific answer. And this is the general case for the derivative of 1 over t squared plus 1. Alright, and then this one again, we're using the difference quotient. We're not nailing down what a is. We're plugging in a plus h into our function. And so we get this big mess, and you can't do anything with that unless you multiply it by its conjugate. And when you do, you get this, a bunch of stuff cancels in the top, then one of the h's cancels at the bottom. And now once you've done that, now you can plug in 0 for h, and you get the same thing on the bottom twice, so you get 2 of them. The top is -6. You can cancel a 2 there, and so you're left with -3 over the square root of 3 minus 6a. And that's for the general case of A.